Hello, good day. My dear students, how are you? By this time, you must have already done all the experiments. So far, the first to submit the experiments 1, 2, 3, 4, Tricia Imbo and Alexa Lynn. These are the two students who submitted and followed by Bernadette. Okay? And before I will proceed to the discussion of the ordinary motion, which deadline will be tomorrow, Friday, July 3, I would like to remind everyone with respect to the compliance of experiments 1, 2, 3, 4 that you are going to follow the instructions. Okay? Of course, Tricia is the only one who submitted a proof of the conduct of the experiment. The proof could be a picture of yourself doing the experiment or a video clip not more than 4 minutes showing yourself doing the experiment. Okay? And I appreciate Tricia for wearing a presentable attire. Remember that I do not like to see my students wearing an attire such as short pants, sleeveless shirt, and similar attire during the presentation. In the case of the experiments, during the conduct of the experiments. Okay, thank you, Tricia. And for the rest, you have to do to follow the instruction about submission of a proof of the conduct of the experiment. Okay? Okay. Another is, I think, those who submitted as of this afternoon, 3 of you, okay, submitted, but unfortunately, there is one instruction that 3 have not followed. And that instruction is on the attachment of units of all the solutions of all the computations. Yes, you have the units, but the units given were only found in the final answer. Every step of the process, first step, second step, third step, and so on until you finish, you are going to show corresponding units of the quantities involved. Remember that this activity consisting of 4 experiments are applications of the concepts and principles of conversions of units. And so, you have a lot of conversions there. You converted drops in 30 seconds, drops in 1 minute, drops in 2 minutes, to drops in 10 seconds. Right? You have that below. Drops in every 10 seconds for the drip chamber and for the tubing end. You also converted the drops to ml. Right? Using the drop factor. You converted that. And also the ml there refers to the volume. Okay? There are 2 volumes there in your experiment. The observed volume, which you had that, okay, from the collected drops using the medicine dropper. The medicine dropper, by the way, the maximum there is 1 ml. So, you are going to have several medicine droppers. Okay? So the drops there converted to ml, to volume. Then, You have their volume in 30 drops, volume in 20 drops, also volume in terms of time, 30 seconds, the volume in terms of 1 minute, and then you converted that to hourly volume, meaning the volume collected in 1 hour, hourly volume. So there is a conversion. So you are going to show the process of converting a quantity to another quantity with the corresponding units shown and the cancellation of these units during the process. Okay? Okay. Now, you have your assignment, chapter 2. Okay? From the textbook, I'm here holding the textbook. I'm going to raise very heavy textbook. This one. Okay, chapter 2. Okay? Okay, chapter 2. You were given problems 1 to 20. Now, all these problems are only considering ordinary motion, meaning motion that involves only the instantaneous speed, okay, the initial speed, the average speed. These are ordinary motions. Okay, now you will be using here the equations provided in the book. For instance, here, problem number 1, the speed of nerve pulses in mammals is typically 10 to the exponent 2 meters per second or 100 meters per second. Okay? Every mammal has what we call nerves and corresponding pulses or pulses. Okay? Now, the mammal considered here, okay, is a large giant whale, 30 meters long whale. Now, 30 meters, if you have gone here in Seliman University, we have a building we call Science Complex Building. Okay, this building is a 3-story building. The physics department is at the 3rd floor. The hallway of the physics department and the biology department, the 2nd floor, the hallway there is about 65.25 meters. That's the length of the hallway. Science complex, hallway, physics department or biology department, they have the same length of hallway, 65.25 meters. Now, if you have a whale of 30 meters, that is half the hallway. Okay, almost half, because half of 65 is 32.5. Okay, so 1/2, 32.5. Now here, the whale considered is 30 meters long. So, very large. Now, in this problem, you're going to draw the body of the whale from the tail to the head. Okay, just a sketch. Okay, from the tail to the head, you indicate there 30 meters. Okay, and that 30 meters is the distance to be traveled by the pulses, because the whale is bitten by a shark. Is this a shark? Let me check. A shark. Then pulses, the pain, okay, will be sent. Then you are asked, how long will it take before the whale knows that this whale is bitten? How long will it take? So you are going to use the ordinary equation of ordinary motion. Long, how long, meaning the time. The time. And so, you have here, you have speed, speed equals distance divided by time. Okay, speed here, small letter V, equals distance traveled. We use the x coordinate, okay? Because parallel to the surface of the earth or horizontal speed, the distance there is x. Okay? Vertical, the distance to be traveled is y. And the third dimension, the z. Okay. We have x, horizontal distance traveled, assuming perfectly parallel to the surface of the earth. Then time. You are asked of how long. So time is x over v. X given, the length of the whale, and the v. The speed, is this the speed? Oh, the speed is given also. The speed is given 10 to the exponent 2 meters per second. Okay? Oh, given, you can solve for the question how long. So, it will take how many seconds? Okay. So, then, next, the world, number 2. I'm looking at the book, by the way. Here. Next, number 2. The world record for 100-meter yard run is 9.0 seconds. What is the corresponding average speed in miles per hour? Oh, conversion from yard to mile. Okay? So, this is distance traveled is 100 yards. Okay. So, this is number 1. Number 2, distance x is 100 yards. Yards. Time is equal to, the time is 9.0 second. Okay? So, the speed here will be x over t. X over t, then 100 yards per 9.0 second. Your final answer will be in miles, miles per hour, miles per hour, miles per hour. Do not give me immediately the final answer. You have to show me the conversion. Okay? So, you cannot directly, okay, have yard to mile. You are going to, what? There is a process there. Mile, convert that to feet, feet to mile. Or, if you, okay, have, if the book provides, the book that you have, the electronic copy of the book or this hard copy book provides direct conversion from yard to mile, well, so be it if it is provided here. But if it is not provided and this is your only source of information, then you go the conversion, yard convert to feet and feet to mile, or yard to meter, meter to mile. Once you adopt such conversion value of once you adopt, okay, conversion values of feet to yard or yard to feet or yard to mile, you are going to show the cancellation. You are going to attach. You are going to attach the units. So here. Number 3, so in other words, there are series of steps here that you are going to show. Number 3, glaciers sometimes advance 20 meters per year. Okay, 20 meters per year. Some glaciers have that speed, 20 meters per year. Question is, what is the speed in meters per second and in centimeters per day? So, your chapter 2 is actually, okay, a continuation of conversions in chapter 1. Remember, you submitted the first assignment on measurement, conversions. until now, I am still checking of the work of your classmates or of some of you who are unable to follow the instruction. So I do not know what score will I give. Okay? So, just follow the instruction I gave. You review my instructions there in the soul. I have my instruction how to solve the assignment, how to present your work. You do the same here. Okay? You have the glacier, according to problem number 3, moving at 20 meters per year. So in 1 year, 20 meters. Now you are asked, what is this 20 meters per year in centimeters per second? Yeah, no, in meters per second. 20 meters per year equals how many meters per second? And also 20 meters per year equals how many centimeters per day? So conversion also you show. So from number 1 up to 20, you only use this equation and the conversion. This is the only equation. If you want to further understand this one, the book provides the explanation. But I'll tell you, it's more on the average speed. It is more on these equations. Okay? Okay, now you have to understand that because the next problems within chapter 2, I will be giving you now acceleration. Okay? Acceleration. So, you kindly prepare for the problems and looking at the problems. Starting problem 51, and probably this will be up to problem up to problem number 67, 51 to 67. The same chapter 2. Okay? By the way, I missed you this day, today. I had a video conference using the big blue button to myself only because nobody attended. It's okay. Probably you were busy. Probably zero internet speed or no internet at all. Okay. That could be a valid reason. But then, my dear students, tomorrow, Friday, July 3, please attend, participate in the video conference using the big blue button. Okay? Okay? Bye.